to GCSE Maths Help. Today we're going to be looking at sequences and the key points you need to know for your exam. Let's get started. Linear sequences are a list of numbers that follow a pattern, usually increasing or decreasing by the same amount each time. You might be asked to write the next numbers in the sequence, or you might be asked to find the equation for working out the nth term in the sequence. In order to work out the nth term for a linear sequence, we need to draw a little table. So our sequence here is 8, 11, 14, 17 and 20 and so on. So the first column in our table is going to be the number term it is. So we'll have the nth term there. So we've got first term, second term, third term, fourth term and fifth term. Our next column is going to be the difference between our terms. So that will be the difference. Our next one is going to be plus/minus, and our last column is going to be the term itself. So the first term is 8, second term is 11, third term is 14, fourth term is 17, the fifth term is 20. So we need to get from 1 to 8. So the difference between our terms up here, we're going from 8 to 11, so we're adding 3. 11 to 14, we're adding 3. 14 to 17, we're adding 3. 17 to 20, we're adding 3. So our difference for this sequence is plus 3. So we're going to times all the numbers in the first column by plus 3. So 1 times 3 is 3, 2 times 3 is 6, 3 3s are 9, 4 3s are 12 and 5 3s are 15. Now the plus and minus column, we need to get from 3 to 8, so we need to add 5. To get from 6 to 11, we need to add 5. To get from 9 to 14, we add 5. From 12 to 17, we add 5. And from 15 to 20, we add 5. So in a linear sequence, that whole column will be the same numbers. Whether it's plus or minus, they'll all be the same. So we can go about now writing an equation for the nth term. We're going to write what's happened from our first column right through to the end of our table. So first, we took the term number, we timesed it by 3, and then we added 5. So if we wanted to find the 7th term, we'd substitute n with 7. If we wanted to find the 100th term, we'd put in 100 into our equation. So our nth term is 3n plus 5 for this sequence. Calculating the nth term for a linear sequence is quite easy to do, but sometimes it's going to be a quadratic sequence, which is a lot more complicated. There's a set process you have to go through, which is one of those things that you just need to learn, step by step, how to do it. So to find the nth term for the quadratic sequence, 4, 15, 32, 55, 84 and so on in the form an squared plus bn plus c, we're going to have a look at the step-by-step process. So the first thing to note is that the difference between each of the terms in the sequence is getting bigger each time, so we know it's not a normal linear equation. The other thing to note is the form that they want us to write the answer in. It looks like a usual quadratic equation. So step 1 is to write out the term numbers, including term 0, which we don't know yet. So n is going to be 0, 1, 2, 3, 4 and 5. So these are our terms. So the next row that we're going to write is row C from our equation up here. So these are going to be the terms. So we don't know what the 0th term is, so that will be a question mark. The first term was 4, the next one was 15, next one was 32, next one was 55, the next one was 84. So the next row we're going to write is going to be labelled A plus B from our equation up here, and this is going to be the difference between the terms. So we don't know the difference between the term that we don't know and 4, so we'll pop a question mark there. So the difference between 4 and 15 is 11. The difference between 15 and 32 is 17. The difference between 32 and 55 is 23. The difference between 55 and 84 is 29. So the last row we're going to write, we're going to label 2a from our equation up here. So a features twice. And this is going to be the differences between the differences. So we don't know the difference between our question mark and 11, so that can be another question mark. The difference between 11 and 17 is 6. The difference between 17 and 23 is 6. The difference between 23 and 29 is 6. So at this point, all of these values should be the same. So now that we've written out all the rows that we need, we're going to write the nth term of the quadratic, but we need to fill in the question marks because these are the values that we need. So we're going to work backwards. So we've worked out that 2a, all of that row, is equal to 6. So we can cross through this question mark and write 6. So now we're going to be able to work out the question mark in the row above. So if the difference between the question mark and 11 is 6, this question mark must be 5. So the question mark above that, if the difference between the question mark and 4 is 5, this question mark must be equal to -1. So the first values in all of our rows are the ones that we need to find the nth term. So that's why we've had to go back and work them out. So to find out a, we know that 2a is equal to 6. So a must be equal to 3. To work out b, we know that a plus b is equal to 5. So if a is equal to 3, then b must be equal to 2. So b is equal to 2. And then our c value is the first one in that row, so that's -1. So we can say that the nth term is an squared plus bn plus c. So we've got 3n squared plus 2n minus 1 is the equation for the nth term of this sequence. Unfortunately, this is one of those processes that you just have to learn step by step. I've tried to do it as slowly and as visually and as simply as I can because it's long and it's boring, but these questions often have loads of marks in them, so if you can follow this step by step process, it should be a really good question to score highly on. I really hope you found this video helpful. If you'd like to have some practice at answering exam style questions on this topic, click the link in the bio below. Don't forget to subscribe to GCSE Maths Help with the subscribe button below, or you can check out my Instagram page at GCSE Maths Help for more videos and tips. Thanks for watching.